Hello, ladies and gentlemen. Today we are going to take a look at starting our 8th unit. But before we can get into radicals and rational exponents and what that all means, we're going to take some time today to review some exponent rules. So basic skill review of what you learned in Algebra 1 and then reviewed again in geometry a few times. We're going to take a look at how we simplify using proper exponents. So for our work today, you're going to need your foldable organizer that you picked up from me from in class, and we're going to glue this into your notes here as soon as we're done taking notes today. You notice down the side we have some tabs. You would want to cut those individually so that you can open each one as it pertains to each individual question we're going to look at. And underneath each one has some words or a description from me already written in there, and all you need to do is write the example in that blank space inside there, okay? When you lift up each tab, there'll be a white space there that you need to write an example. So before we get into the inside of this foldable here, let's add a couple things on the outside. Before we can talk about exponents, we need to know what is the base and what is the exponent. So on the basics tab, the x there is considered the base, and the 4 is considered the exponent. Now we're going to open that tab now and fill in the inside. One side you have the words, then on the other piece you're going to write that example that we're about to see. All right, so inside the tab, when you open it up, you have x to the 4th means we're going to multiply x by itself 4 times. So visually in the example spot over there, that means I have x times x times x times x. X to the 4th means repeated multiplication is happening. 4 x's are being multiplied by themselves over and over and over, if you will. Okay, that's the whole idea of what an exponent represents. Now, how can we simplify using properties of exponents? Well, back to your foldable now. We've filled in this basic tab. Now we're going to go down here to the product rule. Underneath there, you see some words, and we're going to write an example. So here we go. When multiplying things with the same base, you add the exponents. That's the rule. So here's what we have. We have x squared times x to the 3rd. Because these guys have the same base of x, check that out, they both have a base of x, we can write this as x to the 2 plus 3, just adding those exponents, that equals x to the 5th. Now the key idea we should understand is why do we just add the exponents here? You don't have to write the y part down, but you should know where this is coming from, okay? Don't write the y part down unless you really want to. Basically, when we have x squared times x to the 3rd, we have x times x, that's x squared, times another x to the 3rd. This is what x to the 3rd means. And they're being multiplied by each other. Now remember, the whole idea of an exponent is it tells us how many times something's being multiplied by itself. We have 1, 2, 3, 4, 5 little x's being multiplied by themselves, so that means we have x to the 5th. That's why we're adding those exponents, because we're saying how many little x's are being multiplied by themselves. All right, now let's look at the next property in our list. When you're dividing things, when we have division with the same base, we're going to subtract the exponents. So let's switch gears a minute here and talk about division rather than multiplication. What if we had x to the 3rd divided by x squared? What we would do is subtract the exponents. We would say I have x to the 3 subtract 2, which is the same thing as x to the 1. Now with me, let's again talk about y. You don't need to write the y down, but let's think about what is happening. If you have a fraction that has x to the 3rd on top, that means you have x times x times x. If we have x squared on the bottom, we have x times x. Now remembering this whole idea of canceling or simplifying, these guys simplify to make 1. These guys simplify to make 1, so we have 1 times x, which is just x, or x to the 1st. We have one little x left over on the top of that fraction bar after we do the cancel or the simplification here. So that's why we would subtract those exponents. Let's look at our next property. What about if we have things to the 0 power? Well, the rule is any base raised to the 0 power will always equal 1. That means you can have x to the 0 power equals 1, 45 to the 0 power will equal 1, even Kincaid to the 0 power is going to equal 1. It can be variables, it can be letters, it can be numbers, it can be whatever you want it to be, but if it's raised to the 0 power, it's going to equal 1. Why does that happen? Well, again, don't need to write the y part down, but this is what's really happening. Let's go back to when we have x squared on top of x squared, we have division. Remember what this means? We have x times x over x times x. That's what x squared over x squared means. Now, remember when we simplify, the rule for subtraction, or the rule for division, is that we're going to subtract these exponents. So we have x to the 0. That's what this means. 2 minus 2 leaves me with 0. But notice when we actually cancel this, we cancel x over x makes 1. Another x over x makes 1. 1 times 1 is still 1. When you cancel things, they divide to make 1. They don't go away and make 0. They divide to make 1. So the whole idea of having 0 x's left really means we still have a fraction that's equivalent to 1. Okay? Let's take a look at what about negative exponents. The next property, to make a negative exponent positive, we're going to move it to the other side of a fraction bar. So let's take, for example, what if we have x to the negative 1 power? Well, basically right now, this is x to the negative 1 over 1. That's the way it is right now. And because we have a negative power right there, we're going to take this whole base n exponent and move it to the other side of the fraction bar. So we're going to take him and move him to the bottom where he becomes x to the positive 1 now because he's moved to the other side of a fraction bar, and the 1 will just stick up on top because we need to have a numerator for every denominator that we have in a fraction. So basically, when we want to get rid of negative exponents, we're going to move them to the top or bottom of a fraction. All right, let's take a look at what if we have multiple things being raised to a power, okay? When raising a power to a power, we distribute the exponent to everything and multiply the exponents together. So I want to make sure we're clear that this is not the distributive property, okay? Distribute simply, in this case, is meaning give the power to everything. The distributive property we want to take a look at when we talk about multiplying coefficients times multiple terms inside some parentheses. But here we are raising all things in here to the same power of 3. This is a single term, a monomial raised to a power of 3. So that means everything is going to get raised to the third power. We are going to have 2 to the third power. We are also going to have x squared taken to the third power. Now, with that in mind, we're going to then need to remember our rule for multiplying exponents here. We go ahead and multiply the powers when we have something raised to another power. So 2 to the third is 8. X to the 6th is what I would have here on this exponent because we multiply those exponents together when there's a power onto a power. So my simplified answer is 8x to the 6th. All right, let's take a look at another example. When raising a fraction to a power, we're going to distribute the exponents and multiply the exponents together. So even if we have fractions inside of powers here or inside an exponent with some parentheses and we have an exponent raised to everybody, we're going to do the same or similar idea. We're going to have to give the 4 the squared, we're going to have to give an x squared and square it, we're going to have to square a y to the third. So the 4 becomes squared, the x squared is also squared, and the y to the third is now also squared. So basically we have 4 squared 16. We have x to the, we're going to multiply these when we have powers onto powers here, 4. And on the bottom we have a y, and we're going to multiply these exponents to the 6th. So we have 16 x to the 4th over y to the 6th as our example. All right, let's take a look at our last example, just a general example there with all the properties mixed in there. So what if we have this crazy fraction raised to the second power? We got some negative exponents in there to deal with. We have some 0 exponents. We have some like bases. Let's work through this one by one. The first thing I would probably do here is give that 2 power to everybody inside that set of parentheses. So I'd have 4 squared. I also have an x to the negative 2, but if I put a 2 power on that, I'm going to multiply those exponents. So I'd have x to the negative 4th. And then if I go ahead and take y and put another second power on him, I'm going to multiply those exponents. 0 times 2 is still 0. Over, now I have to give that 2 power to everybody on the bottom too. It would become y to the 6th, x to the 8th. Remember, we multiply powers when we're having powers or exponents onto other exponents. All right, now we can deal with what we have going on here. 4 squared is pretty easy to simplify. I would have 16. Now notice right here, this x to the negative 4 is a negative exponent. I need to move him to the other side of the fraction bar. He's going to actually come down here on the bottom and sit next to everybody else down there, becoming x to the positive 4. And now when I deal with the y to the 0, anything to the 0 power is just 1. So I have 16 times 1 on the top. On the bottom of this fraction, I have a y to the 6th, that's no big deal, but I have x to the 4th and another x to the 8th. Remember, x to the 4th means I have 4 little x's, x to the 8th means I have 8 of these little guys, all being multiplied times each other. So how many little x's would I have down there? I'd have x to the 12th. I would add those exponents. So my final answer is 16 over x to the 12th, y to the 6th. So as we deal with exponents, we're going to be using these same rules. These are Algebra 1 rules dealing with basic exponent rules. We're going to eventually apply them to when we have rational exponents, that is, exponents that are fractions. These same rules still apply. So let's get used to the Algebra 1 rules again and get a little review in, and then we'll go ahead and go from there. I want to thank you for taking good notes today and making this foldable, and I will see you later. Kincaid out.